In problem 4, you are given an integer array nums and a subarray from L to R is alternating if one of the following holds. So it could be either either increasing, decreasing, increasing, decreasing, or it could be either decreasing, then increasing, and so on, right? And so in other words, if we compare the adjacent element in this subarray, then the comparison alternate between strictly greater and strictly smaller, right? So let's say there is a starting number, so the next number would be greater, then smaller, greater is smaller, or let's say this is the starting number, it could be either smaller first, then greater, smaller, greater, smaller, greater, and so on, right? So it's a hills and valley kind of structure. So and it says you can remove at most one element from nums, then you select an alternating subarray from nums. Now return an integer denoting the maximum length of alternating subarray, right? That you can select. So we have to find out the maximum length of an alternating subarray that we can select after removing at most one element from the given array, right? And the subarray of length 1 is considered alternating. So for example, if you see in the test case 2 1 3 2, output is 4. So choose not to remove any element. So if you're not removing any element, let's see how the structure looks like. 2, then 1, decreasing, then increasing, then decreasing, right? So it's so all 4 elements is can be taken as alternating subarray. So the answer is 4. So it's a DP problem, I would say. I mean, if you have solved a couple of 1D DP problem, then you might sense like it's a DP problem. But let me explain you how to approach it. In problem 4, we are given an integer array nums, right? And we know that a subarray is called alternating if the number goes up and down consecutively. For example, let's say 1 3 2 4 1. See, up, down, up, down, and so on, right? So this is one of the alternating subarray. Now we are also allowed to remove at most one element from the array such that the length of alternating subarray is maximized, right? Such that we can get the maximum length of alternating subarray, right? So it's a DP problem. So I mean, how you can think of it like, let's say you are at any index, right? Let's say you are at any index I, for example, right? You have a choices, right? You have choice, either you remove that element or not, right? So it's up to you whether you remove that element or not. Now think of it like, can we solve this problem by making a choice at any index based on previous choices, right? So I can either take it or I can either remove it, right? Now these two choices depends on the best choices that is done before, right? That is done before. So in these kind of problem where you have a choice whether to remove it or not remove it, whether to take it or not take it, and that choice depends on the previous best choices, right? So these kind of problems solve using DP, because here you are like you need the solution of a smaller sub problem, right? A smaller sub problem, and that's essentially what DP does. It kinds of store the information for a smaller sub problem and then make use of those smaller sub problem solution to make the solution of bigger problem, right? So that's what DP does. So here the problem is in line with the statement, right? We have a choice, either we remove it or not remove it, and both the choices depend on the best result of the previous choices. So it's essentially a DP problem. Now there are three information required. Let's say you are at index I, right? So one is the index, right? So now I'm trying to build the DP state, right? The state of DP. So one of the state is the index where you are at. Now the second state is whether you whether any one of the number has been removed or not, right? So if the number has been removed before, then since we know that we can only remove at most one number, right? So let's say we have another state, for example k denotes whether the number has been removed yet or not, right? So k can contain 0 or 1. So 0 means no number removed so far, 1 means one number removed so far, right? Now another state is what is the last comparison, whether, I mean, last comparison means whether it was up or down, right? So up means, let's say I denote up as 1 and down as 0. So D is the comparison. So there are only three states required. I, where you are at. D is the last comparison, whether the number was up or down, right? And K is the number of deletions so far, whether it is 0 deletion or 1 deletion. So yeah, that's it. So these three are the states of DP, right? So we would need 3D DP here, 3D DP, DP of size n, 2 and 2, right? So here the definition of DP of I, D, K means, so the definition of DP of I, D, K means the maximum, let me write it down, maximum alternating length of a subarray ending at index I and the last comparison was D. So D could be either 1 or 0. 1 means up and 0 means down. And after K number of deletions. So this is the definition of DP. So see, in any DP problem, the definition is very, very important. If you have a clear clear and understanding definition, you can solve any problem easily. The difficulty in DP problem only comes in the definition. If you don't have a clear and right definition, then you might have some difficulties to solve it, right? So always try to spend some time to find out the correct states and what is the definition of DP. So this is definition of my DP IDK. So max alternating length of any subarray that ends at index I and the last comparison was D and after K deletions, right? So this is the definition. Now let's see how to find out value of DP ID and K, right? So now you want to find out what is the value of DP of I, D and K, right? Actually, I think it would be easy to understand if I explain it through code, right? Because I think like we already know what is the state of DP. I mean, how we come up with DP and how we come up with 3D DP, because there are three states. And after that, we also discussed about the definition of DP. So I think the only thing left is to implement it, right? That's it. So let's directly understand it through code. You would definitely understand it easily. Here is the code of 4 column. So you are given nums array. Just first find out its size. Then we already discussed about the DP approach, right? So this is a 3D DP problem. So the definition of DP of IDK means the max alternating length of any subarray that ends at index I such that the last comparison is D. So D is 0 means the last comparison is down, and if D is 1, the last comparison is up. Up means the current number is more than previous number, right? Greater than previous number, such that the number of deletion is K. So K is either 0 or 1. 0 means there is no deletion. 1 means there is one deletion, and that's it. So this is my DP array, right? 3D DP. So I have initialized it 1 because the max length is, the minimum length is 1 possible, right? Because as per the problem statement, if you have just one element, that is also an alternating subarray. So I just initialize it 1. Then your answer is 1. So starting from index number 1, like from I is equal to 1, I less than I plus plus, just check if your current number is either greater than, whether the current number is greater than previous number or not. Now consider a case when your current number is smaller than the previous number, right? So here your the last is down, right? Down, because your current number is smaller than a previous number. So in this case, if you don't want to delete any number, right? If your K is 0, you don't want to delete. So the only comparison would be, the last comparison is only possible which is down, right? So that's why here the comparison is 0. So dp of I 0 0 means give me the best, like the maximum alternating subarray at index I minus 1 such that the last comparison is up. Since we know that the comparison would be up down up down up down, so if my last is down, the previous has to be up. That's why this is 1. So dp of I 0 0 means dp of I minus 1 1. Since I don't want to delete any number, then this should also be 0. So this is the best answer possible at previous index plus 1 to take this current element, right? Now suppose you want to delete a number, right? So here there are two choices. Either you delete your current number or you delete any one of the previous number from index 0 to I minus 1, right? So if you want to delete the current number, the number present at index I, then nothing changes, right? None of the DP state will change, because it's like it's like there is no element at the current index, right? So nothing changes. But if you want to delete any one of the previous number, then this is interesting. So dp of I 0 1, right? 0 means the last comparison is down, and 1 means there is one deletion. So if you don't delete current number, then it has to be one of the previous numbers, right? So dp of I minus 1 1 and 1. Now since your last comparison is down, the previous comparison has to be up, right? And 1 is the, like, just delete any one of the number from the previous collection from index 0 to I minus 1 plus 1. So this is the dp of I 0 and 1. Similarly, if the current number is greater than previous number, then this has to be state dp of I 1 0. So the last comparison is going to be up, and so the last comparison is up, and whether you want to delete at least one of the number or not. So if you don't want to delete it, then you don't have to delete from the previous number also. So dp of I minus 1 0 0 plus 1. If you want to delete it, if you don't delete the current number, then it has to be one of the previous numbers, right? And if you delete it, then none of the dp state changed. So dp of I minus 1 0 and 1. So here we have deleted numbers, I mean one number from the previous indexes, either like any one of them from 0 to I minus 1, because this will take care of it. So you don't have to think about which one has been deleted. It will take care. So it will give you the best result after deletion one of the number from the previous indexes, right? And it will also give you the max possible alternating subarray length at index that ends at index I minus 1, right? So plus 1, that's it. Now there is a case, let's say I is greater than or equals to 2, right? It means that there is at least 3 numbers possible, right? So here you also have to consider a case when you delete just previous number, right? Just previous number. So in that situation, this is going to be your state. If your dp of L, so here, so this is the case, let me write it down. This is the case when you want to delete previous index number, the number that represents the previous index, that is I minus 1, right? So here I want to delete I minus 1, so your key is always going to be 1 here for sure, because you want to delete the number that represents at index I minus 1, right? So your key is fixed. So there are two choices for comparison, whether the comparison is 0 or 1. So if your current number is more than previous or previous, right? So let me write it down. So you have started from 0, the numbers are 0 1 2 dot 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 dot, then I minus 2, then I minus 1. These are the indexes, then current index I. So here I have deleted this number, right? So I have to compare I with I minus 2. So if your nums of I is greater than nums of I minus 2, then just update dp of I is 0 1. So 0 means your last comparison is going to be down, right? Because your current number is smaller than this number. So the only comparison which is possible is 0. So down. So dp of I down 1 is maximum of this, comma I minus 2. So here it has to be up. Since the last comparison is down, the previous has to be up. So this is up, and the number deleted is here 0, because since this number has been deleted, so none of the number has to be deleted from this index. So this has to be 0 plus 1. Similarly, in reverse way, if this number is greater than this, then the last comparison is going to be up, so this has to be down. Plus 1. Plus 1 means I have taken the current number. And that's it. After that, just update your answer. Answer is equal to max of answer, comma, any one of them 4, right? So at it index, whether this is the last comparison is up or down, whether you want to delete 0 or 1 element. And then return your answer. So yeah, it's a good problem. It's actually a, I mean, more like a thinking problem. The implementation is not that hard, but you have to kind of think in that direction. So I would highly recommend to practice these kind of problem. So one thing I would highly recommend to solve fourth problem always in the Leetcode contest. Like, so whether you solve it during the contest or as a up solve, but always solve it, because yeah, right, in the fourth problem I have most of the time seen DP or graph problem. So it will increase your knowledge and experience in these kind of problem, like for during the contest. So yeah, that's all about today's contest. If you find the video, if you please like, share and subscribe to my channel. You can also support my channel through thanks for watching. Have a nice day.